Welcome and good morning, guys. We are from Group Week 4. I am Bazlin, and here with me is Amber, Lim Yen, and also Divani. Today, we are going to teach about acid and alkali, about properties of acid and alkali. So, from today's lesson, the learning objective is the first one: define operationally acid and alkali, explain examples of acidic and alkaline substance, demonstrate the technique to determine the strength of acid and alkali based on pH value. And the final one is identify the uses of acid and alkali in daily life. So let's move.
Good morning, everyone.
Good morning, teacher.
Morning,
Morning,
teacher.
teacher.
Is everyone ready for the lesson today?
Yes.
Okay, so today we are going to be looking at the topic on acid and alkali. So all of you have actually learned about acid and alkali before when you were in primary school. So this time we'll just be going a little bit deeper since all of you are in Form 2 now.
Okay.
For the first activity, we are going to be looking at the properties of acid and alkali. Now, acid and alkali can be found anywhere. So for today, we're going to be looking at the kitchen. Okay, so this is an interactive image. So when I hover my mouse over an icon, an image or text will pop out, okay? So for the first one, let's look at this one, okay. Divani, can you read what it says, please?
Yes, teacher. Stay hydrated. We need to drink 8 glasses of milk every day. What do I taste like?
Would anyone like to answer, Divani?
I want to answer. I think
Okay,
water is tasteless.
Water is tasteless. That is correct. So now I'm sure all of you remember that there are 3 categories. You have acid, neutral, and alkaline. So if something is tasteless, what category is it in?
Neutral.
Correct. Very good. Okay. Let's go to the next one. Okay. Yen, would you like to read this one?
Okay. Greetings from an orange. People love making me into juice. You can drink my juice as a beverage or use me to flavor your cooking. What do I taste like?
Thank you, Yen. Would anybody like to answer this one? Divani?
Do I taste sour, teacher?
That is correct. Very good. Okay. Now, can anyone tell me if something tastes sour, is it acid, neutral, or alkaline?
I want to answer.
Baxlin?
I think
Oh, it's okay. Yen, you were already answering. What is the answer?
yeah, I think it's acidic.
Correct. Very good. Thank you, Yen. Okay. So now we know that neutral is tasteless and acidic is sour. Okay. Let's look at this. This is a Coca-Cola bottle. Okay. Let's think. This is a Coca-Cola bottle. Carbonated soda is commonly seen in many kitchens. However, what is one characteristic that Coca-Cola has in common with another common household kitchen item? Drain cleaner. Does anybody know what this might be?
We don't know.
Don't know, teacher. I
Okay,
drink
it's okay.
Coca-Cola.
Very good. It's not good for you anyway. Okay. Let's look at this video and let's see what that characteristic. Okay, first, he's cleaning off the protective coating from him, pouring the drain cleaner, and he's putting in the can into the drain cleaner. And you can see something is dissolving. Okay, the metal has come off. Only the now he's taken another can and he's doing the same thing, but he's putting it in the coat. And you can see it had the same effect. So anybody guess what is the characteristic? Yes, Yen?
Teacher, I remember is alkaline. Is it Coca-Cola also is alkaline?
Thank you so much. The first part of your answer actually was correct. It's alkaline, that's very good. But Coca-Cola is actually acidic, it's not alkaline. So what this means is that there is one characteristic that acids and alkali have in common. So based on this video, what do you think that characteristic is? Can anybody tell me?
I know, teacher. It's
Yes,
corrosive. They are both corrosive.
Very, very, very good. So what does this tell you? That both acids and alkali are corrosive. Okay, so if you can see here, there's a second question that says carbonated soda is fizzy, but I am, because when you see, both of them have bubbles. I'm sure you've drunk Coca-Cola before, and you know it's fizzy, that it's bubbly. I hope none of you have drunk drain cleaner, it's not good for you. So, Batslin, would you like to answer this question? For carbonated soda, it's fizzy, but what is drain cleaner?
Maybe soapy?
Correct, it's soapy, because it's not acid, it's alkaline. And that is another property of alkaline, okay? They are soapy, and they are also bitter. Okay, so now let's look at this, okay? What is the similarity between all the items that we saw just now? Lemon juice, carbonated soda, drain cleaner. We know that one is alkali, another one is acid. So what is the similarity? Who would like to answer? Yin?
All of them are liquid.
Correct. You can only see their properties. That means their taste, whether they are soapy. You can only see whether they are corrosive. You can only see all of that in the presence of water. So that's why all of them are in liquid form. Okay. So now we'll just have a quick recap. If you look at the table, you will see for acids, their characteristics are they sour and bitter. For alkali, they taste bitter or feel soapy, and they are also corrosive. Acids and alkali only show their properties in the presence of water, and water itself is neutral, as we saw just now. Okay, very good class. So far, everybody is very well. Everybody is keeping up. Okay. Everybody still okay? Everybody still with me?
Yes, teacher.
Yes, teacher.
Okay, thank you for the response. Okay, now we'll look at the pH scale. So we're going to find out what is the pH scale, and we are going to do a small experiment about how it works. Okay? So we're going to watch a short video. So I prepared this video specially for all of you, and I did this experiment myself at home. So you can watch. All of it is using household items. So if you want, you can try it by yourself also. Okay? Okay, the pH scale. So if you look at this, the pH scale is used to indicate the strength of acids and alkalis. Okay? So this means how strong an acid or alkali is, means whether it's more acidic or it's more alkaline. The range of pH values is 0 to 14. Okay? There's no negative and there's no 15, 16, just 0 to 14. 7, which is the number that's right in the middle, is neutral. Anything less than 7 is acidic, and anything more than 7 is alkaline. So you can see in this small chart here, okay, this is neutral. As the numbers become bigger, it becomes more alkaline, and as the numbers become smaller, it becomes more acidic. Okay? Everybody can understand?
Yes.
Yes, teacher.
Okay. Now we're going to look at the experiment. So in this experiment, I'm using a homemade indicator, and what we are using is cabbage water, okay? Red cabbage specifically. So if you can see, this is the pH scale with cabbage water, and the numbers are 0 to 14, okay? Now the reason I'm showing you this scale is because when you use different indicators, I'm sure you've heard of things like litmus paper and phenolphthalein and all those indicators. Each of them gives a different result because they are different solutions. So they react with mixtures differently. In this case, when the substance is more acidic, the most acidic will be red in color, and it gradually becomes less red, more pink, turns to purple. When it turns purple, it is neutral. That's because red cabbages are purple in color. So when you pour them directly into something neutral, it doesn't react with anything and it stays purple. As it becomes more basic, which is more alkaline, it becomes blue, slowly turning into green, and finally will be yellowish. Okay? Everybody with me? Everybody understanding?
Yes.
Yes.
Okay, let's keep going. So this is how you prepare the indicator. These are the solutions that we are going to use to see what pH they each have, okay? Water, toothpaste, vinegar, carbonated soda, lemon juice, bicarbonate soda, and bleach. Okay, now I'm about to pour the indicator into water. Now, before I continue the video, what color do you think this is going to change into?
Purple.
I think it's purple because water is
Correct.
neutral.
Correct. Very good, Yen. And thank you, Divani, for responding as well. Let's see. Now we are looking at toothpaste solution. So before the video shows when I pour in the indicator, would anyone like to guess? Batslin, would you like to guess what color it's going to turn?
Maybe pink, teacher?
Okay, let's see. Okay, it's a very good attempt, Batslin, but it looks like it's not pink, it's bluish purple. So if it's bluish purple, it means that it's alkaline, correct? Okay, now let's look at the next one. So now I'm going to put in vinegar. Okay, would anyone like to guess what color vinegar is going to turn?
Me, teacher.
Yes, Tivani.
Pink color.
Pink color. Okay, let's see. Okay, well done. Correct. It's pink. It's a dark pink, but it's pink. So that means that it's acidic. Correct? Yes, very good. Thank you. Okay, now we'll look at the next one. Carbonated soda. For carbonated soda, Yen, would you like to try? What color do you think it's going to be?
I think is red color.
Red color. Okay, let's see. Okay, it's not red, but you were in the correct range, Yen, so very good attempt. This is a dark pink, so it's definitely acidic, like we learned earlier, isn't it? Carbonated soda is acidic. But what this shows is that although something is acidic, there is a range to how strong its acidity is. So this isn't strong enough to be red, but it's still acidic because it's pink. Okay, very good. Let's see the next one. This is bicarbonate soda, not carbonated soda, bicarbonate soda. Okay, but Celine, would you like to guess what color this is going to turn?
Pink?
Pink. Okay, let's see. Oh, it's turned blue. Thank you, Vaseline. But the answer is alkaline because it's blue. So all of you need to make sure you don't get confused, okay? Carbonated soda is acidic, but bicarbonate soda is alkaline. See, it's a deep blue color, okay? But thank you, Vaseline, for trying, okay? Now we look at lemon juice. Okay, so just now we spoke about juice also, isn't it? So Divani, what do you think this is going to be?
Bright pink.
Bright pink. Okay, let's see. Okay, that is actually red, not so clear through this video, but it's actually red color. So this is because lemon juice is very acidic. Okay, thank you, Divani. Your answer is correct. So now the last one is bleach. Okay, bleach. Yen, what do you think is going to be?
I think bleach is very alkaline, so maybe it's yellow color.
Okay, thank you, Yen. Let's see. Yes, Yen, you were correct. It is yellow color. So, class, you have to see that this means that this is very, very alkaline. Okay, similar to the drain cleaner that we saw earlier. You can see the colors more clearly now when more indicator is added. Can you see the lemon juice is red? Okay. So if you all noticed, just now when I showed you the indicator for the cabbage water, the colors were from red until neutral, which was purple, and then it went to blue, and then greenish until it reached yellow, correct? So now I'm going to arrange the liquids according to the pH scale in the video, and let's see if you can guess the arrangement correctly. Okay, the first one I've shown you, it's lemon. I'm sure you all knew that since it's red. What do you think the second one is going to be?
Vinegar.
Vinegar, okay? Because it's also pink, correct? Let's see. Correct, very good. So now the third one, what do you think it's going to be? Who would like to take a guess?
The pink one.
What is
The
it,
red one.
Roslyn?
I'm sorry, teacher. I forgot.
Okay, it's carbonated soda. But very good. You're still correct, so thank you. Okay, so if you can see from the 7 mixtures that we did, lemon, vinegar, and carbonated soda were acidic. Okay, and you can see red to pink to darker pink. So of course, the middle one is water since it's neutral. So after water, what do you think is going to be the least alkaline? Jane, would you like to guess?
Toothpaste water.
Toothpaste water, very good. Let's see. Yes, it's toothpaste water. Very good. Okay. Now the sixth one. What do you think is going to be after toothpaste water?
Me, teacher.
Yeah. Yes, Divani?
Bicarbonate soda.
Bicarbonate soda. Okay, let's see. Yes, correct. Well done, Divani. And so now we know that the last one is bleach. So as you can see, from this experiment, we've managed to replicate the scale that I showed you earlier in the picture. All of you can understand?
Yes, teacher.
Yes.
This is
So you
so
see
fun.
so when you can see that actually what the pH scale does is it effectively shows us the strength of each acid. For example, carbonated soda, although it's acidic, it's not as red as lemon juice because it's not as acidic as lemon juice. Okay. Let's continue the video. So now we've reached the recap. So the correct sequence of increasing pH values in pH scale is acidic from most acidic to least acidic, followed by neutral, and then the least alkaline all the way to the most alkaline. Okay, so that is 0 to 14. So from the samples that I showed you earlier, the acidic substances were lemon juice, vinegar, and carbonated soda. Order of decreasing acidity. Neutral was water, and for alkaline, it was toothpaste, bicarbonate soda, and bleach, in order of increasing alkalinity. Okay, everybody can understand the pH scale? Do you have any questions to ask me?
No, teacher.
No question.
Okay, I have to say all of you did very well. You answered the questions, so thank you very much, okay?
Thank you, teacher.
Okay.
Okay, student. So we shall continue to the next subtopic. So before this, we have already learned about pH, the property of acidic, okay, and alkaline solution, and also we have learned about pH scale. Okay, so we know that a smaller pH means that it indicate is acidic. Smaller than 7 means it's acidic, and then 7 pH 7 means neutral, and then pH larger than 7 means it is alkaline. So my question for you now is, do you know how to test pH?
Yes, teacher. We
Anyone
drink
know?
cabbage
Teacher.
water.
Yeah? Yes, very good, Diwani. We have already learned about the cabbage water, but today we are going to learn, okay, using a chemical indicator, okay, and also pH meter. Okay, so later I will show you a video, okay, on how to use pH meter and other indicator, like for example, we have universal indicator, litmus paper, okay, and then we have methyl orange indicator, and the last one will be phenolphthalein. Okay, so I hope that you can pay attention during the video, and then I will ask you question. We will do a small revision after the video. Is that okay?
Okay, teacher.
Okay.
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 Bring the homogenized water sample in a glass beaker. Now insert the probe in the sample and wait until a constant and unchanged. Bring the homogenized water sample in a glass beaker. Now insert the probe in the sample and wait until a constant and unchanged reading is given. This is the final unchanged reading. So the pH of the sample is 5.56.
While it is possible to quantitatively measure the pH of a solution using a device known as a pH meter, there are also ways to determine pH qualitatively. In this lesson, we will learn about indicators, which help us indicate the pH of a solution. An indicator changes color depending on the pH of the solution analyzed. Because of this, they are also known as pH indicators. While it is possible to quantitatively measure the pH of a solution using a device known as a pH meter, there are also ways to determine pH qualitatively. In this lesson, we will learn about indicators, which help us indicate the pH of a solution. An indicator changes color depending on the pH of the solution analyzed. Because of this, they are also known as pH indicators. Universal indicator is very versatile as it can measure pH across the entire scale from 0 to 14. It is not a single indicator, but rather a combination of various indicators. If you look at the color changes of a universal indicator according to the pH of a solution, you will find that it resembles a rainbow. If universal indicator solution turns deep red in a solution, it means that the solution is strongly acidic, with a pH of 1 to 2. If the universal indicator solution turns green, it means that the solution is neutral with a pH of 7. If the universal indicator solution turns dark blue or purple, it means that the solution is strongly alkaline. Universal indicator paper works in exactly the same manner. Litmus is another indicator commonly found absorbed onto paper as litmus paper. Blue litmus paper turns red under acidic conditions, pH less than 7. Red litmus paper turns blue under alkaline conditions, pH greater than 7. Phenolphthalein is an indicator commonly used to determine the endpoint of a strong acid, strong alkali, or weak acid, strong alkali titration. It goes from colorless to fuchsia pink at a pH of 8.2. Methyl orange is used to determine the endpoint of either a strong acid, strong alkali, or strong acid, weak alkali titration. It is red at a pH lower than 3.1 and yellow at a pH higher than 4.4. In conclusion, indicators are substances that change color at a certain pH. The point at which an indicator changes color is known as its endpoint, which can be at any pH. Common indicators that you will encounter are universal indicator, litmus in the form of litmus paper, phenolphthalein, and methyl orange.
Okay, so are you clear on how do a pH indicator works now?
Yes,
Yes,
teacher.
Yes, teacher.
Okay, then let's try this out. Okay, it's a revision, okay, on what we have learned in the video just now. Okay, so we have a glass of water here. So in the water, we've put a few drop of universal indicator. So can you please guess what will be the final color of the universal indicator in the water? Can anyone guess?
Blue color, teacher.
Blue color. I heard Diwani reply blue color. Okay, so let's see the answer. Okay, very good, Diwani. You have answered my question, but the answer is actually green color because water is neutral. It has a pH of pH 7. Okay, good try, Diwani. Okay, let's go to the next question. Toothpaste. Okay, but this time we're using red litmus paper. So if we put toothpaste on red litmus paper, so what will be the color of red litmus paper? Is it will remain red or is it going to turn blue? Can anyone try?
turn blue,
Blue.
teacher. Turn blue.
Very good, Amber. Okay, it will turn blue. Okay, you can see that in this picture, the red litmus paper has turned blue color. Very good. Okay, we go to the last question. We have a vinegar here. Okay, so this time we're using methyl orange indicator. So this is how the methyl orange indicator looks like. So we're going to drop a few drops into the vinegar. So what will be the final color of methyl orange indicator? Is it going to be red or yellow?
Red.
Very good. Okay, it's going to be red in color. So that's all that we have to learn for the pH indicator and also how do we use pH meter. Any question from you?
No,
No,
teacher.
No, teacher.
Very good.
So, hi guys. Now we are going to learn about the uses of acids and alkalis in our daily life. So, let's move. So, the first acid is tartaric acid. So, can anyone guess what is the uses of tartaric acid?
Not sure,
No,
teacher.
No, it's okay. So the uses of this acid is it is added in foods to give a sour taste and serving as an antioxidant. It is popularly used to enhance the quality and stability of a variety of foods. The second one is carbonic acid. This acid is really famous in our daily life. So can anyone guess what is the use of this acid?
Carbonated
Does it have
soda,
something
teacher.
with carbonated soda?
Yeah. Correct. So this one is used in the preparation of bubbly drinks such as soda, soft drinks, sparkling wines, and other aerated beverages. And the last one is sulfuric acid. So this one, can anyone guess? Seems like
Not
all of
sure.
you seems confused. So this acid is used in production of fertilizers, chemicals, dyes, glass, paper, soaps, and also textiles. So for the next part, we will see the uses of alkali in agriculture. So for the first one, alkali is used in lake treatment. So in lakes impacted by acid rain, the application of calcium carbonate dropped by airplanes can control and neutralize the water's pH level. So as you guys can see in this picture, there is a airplanes and this one is alkali. So this is used to neutral the pH as the pH of the water. So the second one is used in sewage treatment. Sodium hydroxide can convert waste products by maintaining the correct pH for oxidation of sewage. So we will move to the next part. Uses of alkali in industrial sectors. So I guess, can anyone of you guess what is the use of alkali in industrial sectors?
Detergent,
Maybe Divani?
teacher.
Detergent. Wait. Yeah, correct. So the first one, sodium hydroxide can neutralize acids in different types of dirt and soil to remove scuff marks, water emulsion waxes, and also accumulated dirt. And the second one, can anyone guess? Yeah? No.
Not sure.
All
teacher.
right. Not sure. It's okay. Let's see. So the second one is used in ceramic products. Potassium oxide are a principal raw material in glass. Stronger alkalis can create a brighter color response in glazes. So that's all from my part. I hope all of you can understand about the uses of acid and alkali in our daily life. So guys have any question?
No, teacher.
No, teacher.
No. Alright, so that's all from me.
Okay, class, we would like to wrap up this lesson. So before we do that, let's do some recap on it. So today you have learned the properties of acid and alkaline, the pH meter, the pH scale, and different experiments using different chemical indicators. But we have also learned to make our own indicator at home using the red cabbage. So we shall wrap this lesson up by doing an online quiz on Kahoot, because to add some fun to it, you don't feel bored doing your regular paper and pencil quiz. Okay, so to do that, I want you guys to go to the website, Kahoot It website, and then put in the game pin and join. Then we can start the quiz.
Okay, teacher.
Alright, teacher. Teacher, my phone still loading.
Yes, we shall wait for you, Bazin, don't worry.
Alright.
Okay, I can see you, Bazlin. Amber, is your phone okay? Can you join?
Connecting, teacher.
Okay. I see Yen, you're very excited to do a quiz.
Yes, teacher.
Okay.
Can you see me, teacher?
Yes, okay. You're all three joined already. So shall we start?
Yes, teacher.
Okay, let's start. So this question is double points. What is the pH of distilled or pure water? Okay, so I see two of you managed to answer. Another person, did you not manage to answer?
Oh, sorry, teacher, because from the minimized screen, I couldn't see the question.
Oh no, Amber. It's okay. So can you see it clearly now?
Yeah, now because I've returned to the main screen. Sorry, teacher.
Okay, it's okay. So just now, our first question is, what is the pH of distilled or pure water? So Amber, since you didn't answer, what is the pH?
7, teacher.
Okay, so all of you know water is neutral. So the neutral pH is 7. Okay, everybody's clear? Okay, now go to the next question then. Wow, Baslin is leading. Hopefully everybody can catch up to her. It's a true and false question. So you have to guess whether this solution is acidic or not. I see. So one of you only managed to answer? The other two? Who did not manage to answer?
I don't think I managed to, teacher. I think my internet was a bit slow.
Okay, never mind. Okay, so the picture was a litmus paper turning to blue. Would you say the solution is acidic or alkaline?
Alkaline.
Alkaline.
So that's why this
Alkaline.
statement is false. Okay, let's try the next question. Hopefully everybody got good internet. And then Baslin is still leading. Okay? Congrats, Baslin. Okay, and the next question. Which of the properties below does not suit an alkaline solution? Okay. One of y'all answered the pH is more than 7. And one of y'all answered the pH is less than 7. So because they say does not suit. So that means the clue here is you have to find the wrong answer, right? So that's why the answer is pH value less than 7, because pH value less than 7 would be acidic solution. Okay? Okay, I hope everybody's
teacher.
clear. Amber, is your internet still not good?
I'm not sure, teacher, because when I click on the answer, it still says time's up.
I see. Okay, let's try again. Okay, next question. Okay. So this is a double point question. Which substance is acidic?
Teacher, do you think you could read out the options for me?
Okay, the red one would be bleach, yellow lemon juice, blue detergent, and green water.
Okay, time's up.
So sorry, I have to move your screen. Okay.
It's okay.
Okay. Okay. So here, because they say acidic substance, so it's okay, Amber. Now I will read out the answer for you. Which of the substance is acidic? Bleach, lemon juice, detergent, or water?
Lemon juice.
Okay. So it's lemon juice because, as we know, lemon juice is acidic, detergent and bleach is alkaline, water is neutral. Okay. Let's try the next question. Okay, Yen's leading now. Okay, but Basley, you can catch up. Okay, next. Is acid used to make car battery? True or false? Blue is true, red is false. Okay, so one of you answered true, one of you answered false. So as you can see in your textbook, sulfuric acid is used to make car battery. So that's why acid is used to make car battery. So it's a true statement. Okay? Okay, and the next question. What color does universal indicator change to in an alkaline solution? Sorry for the typing error there. It's change. So I see. Okay, so one of you answered red. As you all know, universal indicator has only 3 color options. Would be 3. But alkaline solution has a color change of blue. Okay. Okay, the last question is a true or false question. Does the yellow color change of methyl orange indicator mean the solution is acidic? Blue is true, red is false. Okay, so the answer is false. So the yellow color change in a methyl orange indicator mean the solution is alkaline, not acidic. So if it's acidic, it will change to red. Okay, everybody understood?
Yes,
Yes,
teacher.
teacher.
Okay,
Sorry,
so
my internet was very slow.
it's okay. It's okay. I'm glad you tried with with the internet issues also. As we all know, online studies is always like that. So congratulations, Yin. I am sure the rest of y'all also paid attention, and due to internet issues, you would have had some complication. And I believe you all understand this topic very well. So again, congratulations to Yin, Bazlin, and Amber, and hopefully you guys will keep practicing on this topic. So to help you on that, I have prepared some homework for you in a form of Google form. So I will send that to your class group, and I hope you guys can do it, and then we will discuss it in the next class. So this question is a bit more complicated than what we had here, because here is more fun and easy kind of quiz. So that has, you can short form questions, multiple choice, and a checkbox question. So everything you can do it on the Google form, and hopefully you get to answer all, and you can even flip your textbook if you don't understand. Okay? Okay then.
Okay.
I
Thank you,
hope
teacher.
you enjoyed today's class and you understand. Do you have any question?
No,
No,
teacher.
teacher.
Okay then, if that's all, then if that's the case, then I will see you all in the next class. Thank you.
Thank you,
Thank you,
teacher.
teacher.